We're going to be talking about intercepts. And the reason why we want to know a little bit more about intercepts is because it offers us a whole new way to graph lines. So far, lines have been given us in the equation y equals mx plus b. And it's been really simple to identify the starting point and then use that slope to get us more and more points on that line. Now, in today's lesson, lines are not going to be in y equals mx plus b. Or maybe we'll start with them in y equals mx plus b, and then maybe have them not in y equals mx plus b. In order to just show that, it doesn't really matter what form a line is in, we can always graph it. So first, let's talk about an x-intercept. This is a little bit, maybe we have an idea of what an x-intercept is, but we haven't really deliberately talked about it specifically. And well, it's just a point on the graph where the line hits the x-axis. And if we have this graph here, you notice that this line crosses the x-axis right at positive 8. So we can say that this line has an x-intercept of positive 8. Now, the y-intercept, we're very familiar with it, and it's a point where the line crosses that y-axis, and this particular line crosses the y-axis at positive 4, right? So, nothing crazy so far. Now, finding intercepts. Now, what do all of the points on the x-axis have in common? Well, let's have a look. Let's grab a random point like this. Let's grab, this is 2, 0, 5, 0. Okay, we got 8, 0. Do you see a pattern here? Let's check over here. Negative 3, 0. We have negative 7, 0. And if you take a moment to just think about what's going on here, you might notice that every single one of these coordinates on the x-axis have a y value of 0. And that's true for every single coordinate on the x-axis. Now check this out. How about all the points on the y-axis? What do they have in common? Let's start off with this one. We have 0, 2, 0, 6, 0, 9, 0, negative 5, and 0, negative 8. What do all of these points have in common? Well, the x value of each coordinate is always 0. Now, what we can do here, folks, is we can actually use that as like a strong arm to solve for the x and y intercepts. Like, if an x-intercept has a y value of 0, we can use that 0 to help us get the x-intercept. And if the y-intercept has an x value of 0, then we can use that value of 0 to get our y-intercept. Let's go ahead and I'll show you exactly what I mean here, and we'll start off with some familiar territory in y equals mx plus b. So let's do an example. It says here, find the y-intercept of the line y equals 4 over 3x plus 5. Now, I know there's probably many of you out there thinking, well, we already know exactly what the y-intercept is of this line. And if you're thinking that the y-intercept is positive 5, then you're absolutely right. That's totally right here. But I just want to show you how we could use that, when a y-intercept exists, the x value is 0. Check out how that kind of works here. So here, let's do an algebraic solution. We could just draw the graph, but, we could it'd actually be all right to draw the graph here. It says for the y-intercept, the x value should be 0 in that coordinate. So what we can do is just put that x in the equation. We'll set it to 0. So we'll sub in 0 for x, and then we'll solve for y. So 4 over 3 times 0 is 0, plus 5 is just 5. And maybe that algebra didn't really do it for you. You're probably not impressed right now. So the y-intercept here is at positive 5. And on a graph, what that would mean is we plot our point at positive 5 on the y-axis. Now, algebra aside, you probably already knew that, but let's now use this to kind of get the x-intercept. This algebra confirms that the y-intercept is 5. It confirms it algebraically and also using what we already know. We already kind of knew it was 5. So how about this one? Find the x-intercept of the line 2x plus 7y plus 8 equals 0. See, this is a line that this is an example of a line that we're going to be tackling today. Notice how it's not in y equals mx plus b. It's actually a little bit of a weirder form. We call it standard form. So here's a solution. We could just draw the graph. Could we? I don't know. For the x-intercept, the y value should be 0. So what we're going to do here is we're going to now set the value of y in that equation to 0 and then solve for x. So what that'll look like is this. We'll start off with the equation. 2x plus 7y plus 8 equals 0. And then, since we know at the x-intercept the y value is 0, we will replace y with 0. So we have now 2x plus 7 times 0 plus 8 equals 0. 7 times 0 is literally 0. So we have 2x plus nothing plus 8 equals 0. We can kind of get rid of that plus 0 there. So we have 2x plus 8 equals 0. And now we're just solving for x. So we're going to bring that 8 to the other side. So now it becomes minus 8, of course. And then at this point, we can divide each side of the equation by 2. And we end up with an x-intercept of negative 4. So the x-intercept is negative 4. So on a graph, what that means is we have a coordinate at negative 4, comma 0. And that should feel all right. Like when y is 0, we sub in 0 for y, x is negative 4. So as a coordinate, we get this negative 4 for x and 0 for y. Okay, let's do an example. So I think at this point, you're going to have to write this down. We have an example here. It says, use the x and y intercepts to draw the graph of the line 2x minus 3y equals 15. Now, what you could do is, many of us tend to kind of work ahead while I'm teaching, which is totally fine. But if you did want to have a shot at this by yourself, go right ahead and start right now. But what I'm going to do is I'm just going to take this up really slowly. So in order for me to do this properly, I'm going to have to move over to Active Inspire. So it says it's the same question here. So the first thing I think we want to do here is solve for, well, I guess the x-intercept, because it says use x and y intercepts to graph this. So let's go ahead and solve for the x-intercept. Now, whenever we're solving for intercepts, I often use this title. It says solve for x-intercept. And then right underneath that title, I remind myself that in order to do that, we have to set the y value to 0, right? Because on the x-axis, y is always 0. So the first thing we're going to do is write the equation. We're just going to restate it so we have it written right here. 2x minus 3y equals 15. And then what we're going to do here is we're going to replace this y in the equation. We're going to replace it with 0. So we're substituting in 0 here. So it'll look like this. 2x minus 3 times 0 instead of minus 3y equals 15. And then we're just going to now solve for x. Negative 3 times 0, right? We got here 0. 2x minus 0 equals 15. And I guess 2x minus nothing is just 2x on that left-hand side, right? 2x equals positive 15. And then at this point here, we're going to get rid of that multiplying 2 by dividing each side by 2. And I think you're really good at this. And then these 2's cancel, of course. Just, whoop. It's not a good color to use. They cancel just like that. And we are left with x equals 7.5. I know, decimal, it's not pretty, but it's there. So what this means is this. X equals 7.5. As a coordinate, we now have one coordinate on our graph. We have 7.5, comma 0. And that deliberately reflects, x and y. Like, don't forget, y we said was set to 0, and that's why in our coordinate y is 0. And then the x ended up being 7.5. So when y is 0, x is 7.5. Okay? Now, I guess next what we can do is solve for the y-intercept. And in order to do that, we will have to set the value of x equal to 0. Okay, now, in our equation, we first start off by rewriting the equation. These little titles are super helpful. I highly suggest writing these titles. Then start off with the equation, absolutely. And what we're going to do is we're going to replace this x with 0. So it'll be 2 times 0 minus 3y equals positive 15. Now, 2 times 0 is just 0. So you could write 0 minus 3y equals 15. And if you're thinking to yourself, do we really have to write this step right here? Like, is this step really necessary? Absolutely. Is this step really necessary? I want to say absolutely. And the reason why is because, well, 0 minus 3y equals 15. Now, what you're left with here is not just 3y. You're left with negative 3y. And sometimes we could miss that really, really easily. So just be very cautious with your algebra. At this point, we divide each side by the coefficient, which is negative 3. The negatives cancel, the 3's cancel, and we're left with y equals, well, 15 divided by negative 3. My calculator says that is negative 5. So y equals negative 5 right there. So as a coordinate, think about this as a coordinate. X is 0, y is negative 5, so we'd have the coordinate 0, comma, negative 5, Mr. Yakimishin. That's exactly what we'd have. All right. Great. So close. I was doing so good. Okay. Now on the graph, let's actually plot this on the graph. We have the first coordinate, which is 7.0. Let me write the coordinates here. We have 7.50. And then we have 0, comma, negative 5, right? Let me just go ahead and double check that we have that correctly. 7.50, 0, negative 5. Okay, we're good. We're good. So here we go. We're going to graph this first coordinate here. It looks like it is right here, right between 7 and 8 for an x-intercept. Not pretty, but it'll do the trick. And we got a y-intercept at negative 5. Yeah. And then from here, what we're going to do is connect the dots. Do we need more points? Not really. Whoops, wrong color. We don't really need more points. If we had more, that'd be great, but we don't. So all we really need to graph a line is 2 points. So using some sort of ruler, try your best to graph this line just like that. And that's how we graph lines using intercepts. Okay? So what I'll do is maybe I'll go back. So actually, let me go ahead and label this really nicely here. This line is 2x minus 3y equals 15. That's what this line is. Perhaps we'll label it. Perhaps if you really like, we can label the coordinates, right? 7.50 and 0, comma, negative 5. Silly, Mr. Yakimishin. And that's about it, folks. So I'll go back here. To solve for the x-intercept, we set y to 0. Solve for the y-intercept, we set x to 0. And just use our algebra skills, solve for those x-intercepts, and then graph them on a line. Folks, we need you to get really good at this because later on in this unit, this is going to be a wonderful way to jump some hurdles. So, without further ado, I'm going to stop talking before I start rambling forever and have a great rest.